Imagine a world the size of Earth perhaps, or larger, a giant of ice and storm like Jupiter, a world with mountains, with valleys, perhaps with frozen oceans buried beneath sheets of crystalline rock. But this world has no sun. It drifts through the dark spaces between stars, alone. There is no warm light on its surface. There is no day and no night, no seasons, no weather in the way we understand weather. The sky above this world holds only the faint, distant pinpoints of other suns, none of them its own, none of them close enough to warm it, none of them aware that this world exists at all. We call these worlds rogue planets, free-floating planets, wanderers. They are some of the strangest objects in the cosmos. They are planets, worlds with mass and gravity and surfaces, but they have no home. They orbit nothing. They travel through the dark, alone, sometimes for billions of years, sometimes forever. For most of human history, we did not know they existed. We knew of stars. We knew of moons. We thought planets could only exist in orbit around stars, like the 8 planets of our own solar system, circling our sun in patient ellipses. But over the past 30 years, slowly, we have begun to discover the wandering worlds. There are more of them than we ever expected. The latest estimates from astronomers suggest that there may be billions of rogue planets in our galaxy alone. Some studies suggest the number is far higher than that, perhaps trillions. There may be more rogue planets in the Milky Way than there are stars. This is one of the most surprising discoveries of modern astronomy. Worlds by the trillions, drifting alone through the dark. Tonight, we will follow them. We will visit the worlds that were born without ever having a sun. We will follow the planets that were violently cast out of their solar systems. We will drift across the deep emptiness between stars, where these wandering worlds glide silently through space. We will look beneath their cold surfaces and ask whether life, somehow, might still be possible. There is no rush tonight. There is nothing to fear in this story. Just close your eyes or let them rest gently on the screen. Let your breathing slow. The cosmos is patient. It has waited 14 billion years to teach us about its wandering worlds. It can wait for us a little longer. Welcome to Sleeping Galaxy. If you're new here, you can subscribe to drift through the cosmos with us each week. Tonight, we follow the rogue planets, the worlds without a sun. There are 2 kinds of rogue planets. Some were born in solar systems and were later thrown out violently by gravitational forces beyond their control. We will visit those next, but others were never part of a solar system at all. These rogue planets formed alone in the deep cold of interstellar space. They were born from the same gas clouds that produce stars, but their masses were too small. They could not become stars themselves, and there was no nearby star whose gravity could pull them into orbit. So they simply drifted from the very moment of their birth. These worlds are sometimes called isolated planets or substellar objects. To understand them, we have to begin with the process that creates all stars. Stars are born inside vast clouds of gas and dust, molecular clouds that float between the existing stars of a galaxy. These clouds can be enormous, sometimes hundreds of light years across. They are cold and they are dark. They contain the raw material of new stars, mostly hydrogen, with traces of heavier elements left behind from the deaths of older stars. In a few places within these clouds, the gas is just slightly denser than its surroundings. Gravity pulls a little harder. Slowly, over hundreds of thousands of years, these denser regions begin to contract. They grow warmer, hotter, more compact. If the contracting region gathers enough mass, it eventually reaches the temperature and pressure required for nuclear fusion. Hydrogen begins to fuse into helium in the core. A star is born, but fusion requires a minimum mass. For hydrogen fusion, the kind that powers stars like our Sun, the contracting cloud must have at least about 8% of the Sun's mass. Below this, the cloud collapses, but it cannot ignite. Whatever forms is something less than a star. These objects, between 13 and 75 times the mass of Jupiter, are called brown dwarfs. They are stars that almost made it. They glow faintly with the heat of their birth, slowly cooling over billions of years. They never become true stars. But there is another category, smaller still. If the contracting cloud is below 13 times the mass of Jupiter, even deuterium fusion, the easiest form of fusion, requiring the least mass, cannot ignite. The result is something even fainter than a brown dwarf. It is, by mass and by structure, a planet born alone. In 2023, the James Webb Space Telescope made an extraordinary discovery in the trapezium cluster, deep within the Orion Nebula, a stellar nursery where new stars are being born right now. Astronomers Samuel Pearson and Mark McCaughrean used the telescope's near-infrared cameras to look at this region in unprecedented detail. They found something they did not expect. 540 Jupiter-mass objects, planet-sized but with no host star, drifting freely, just over 1 million years old. In a galaxy that astronomers had assumed was filled mostly with stars and their orbiting planets, here was an entire population of planets without stars, in a single nebula, in one star-forming region. And the discovery grew stranger. 40 of these isolated planets were not alone. They were paired with another planet of similar size. 2 planet-sized objects orbiting each other through the void. The astronomers gave these pairs a name. They called them jumbos, Jupiter mass binary objects. This was something nobody had predicted. 2 planets orbiting each other with no star at all, drifting through space together, separated by anywhere from 20 to 400 times the Earth-Sun distance, slowly circling for what may be millions of years before drifting apart. How they form is still a mystery. Some scientists believe they may have collapsed directly from small fragments of gas in the molecular cloud, born together as twins. Others suggest they may have been ejected from a larger system together, somehow staying paired even as they were thrown out into the dark. We do not know which. We know only that they exist, that they drift, paired or alone, through the cosmic void, that for every star you see in the night sky, there may be one or many planets that have no star at all. These wandering worlds, born without a sun, are some of the most numerous bodies in the universe, and we are only beginning to understand them. But not every rogue planet was born this way. Some, perhaps most, were born in the way we expect. They formed inside a normal solar system. They orbited a star. They had a sun, like Earth has the sun. And then something happened. Something violent and ancient and impossible to undo. They were ejected. To understand how, we have to look at how solar systems form. A young solar system is not the calm, ordered place we know our own solar system to be. Our sun is 4.6 billion years old. The planets have settled into their stable orbits over billions of years. The chaos is long gone. But a young solar system, in the first 100 million years of its life, is a violent place. Around a newly formed star, a flat disk of gas and dust forms, the protoplanetary disk. Over millions of years, the dust within this disk clumps together. Small grains become pebbles. Pebbles become boulders. Boulders become small worlds called planetesimals. Planetesimals collide and merge, slowly building into protoplanets. In the early stages, there are not just 8 planets, like in our solar system today. There are dozens, sometimes hundreds. Most of them are small. Some are larger than Earth. A few may be larger than Jupiter. They are crowded. They orbit close together, in unstable patterns. Their gravity pulls on each other constantly, and gravity in such a crowded place is dangerous. When 2 large planets pass close to each other, they can transfer energy through gravitational interaction. One slows down, the other speeds up. The one that slows may fall inward toward the star, sometimes plunging into it. The one that speeds up may be flung outward, out of its orbit, out beyond the other planets, sometimes out of the solar system itself. This is called gravitational ejection. Once a planet has been thrown outward at high enough speed, it cannot be pulled back. It escapes the gravity of its parent star. It begins to drift through interstellar space, alone. The planet does not die. It does not break apart. It simply leaves. In our own solar system, the early dance of the giant planets, Jupiter, Saturn, Uranus, and Neptune, almost certainly ejected several worlds. Computer simulations suggest that early Earth had a 5th giant planet, sometimes called the Lost Ice Giant, that was thrown out by Jupiter's gravity early in solar system history. That planet, if it existed, is somewhere out there now. It has been drifting, alone, for over 4 billion years. Recent studies suggest that ejection is common. Most solar systems probably eject at least one planet. Many eject several. Astronomers now believe that for every planet currently orbiting a star in our galaxy, there may be at least one rogue planet drifting alone in the cold space between. Perhaps more. The astronomer Andrzej Udalski of the University of Warsaw and his colleague Subo Dong of Peking University have argued that rogue planets may be several times more common than stars in our galaxy. There are about 100 billion stars in the Milky Way. There may be hundreds of billions, or even trillions, of rogue planets. In the year 2024, on May 3rd, ground-based telescopes detected something unusual. A brief, faint magnification of a distant star, what astronomers call a microlensing event. At the same moment, the European Space Agency's Gaia Space Telescope detected the same event from a slightly different angle in space. By comparing the two observations, astronomers were able to triangulate the position of the object, causing the magnification. They could not see the object itself. It emitted no light, but its gravity was bending the light of the star behind it, allowing them to measure both its mass and its distance. The mass turned out to be about 70 times that of Earth, slightly less than Saturn. The distance was about 10,000 light-years from us, deep toward the center of our galaxy. It was the first time astronomers had directly measured the mass and distance of a rogue planet at the same time. The discovery was published in the journal Science in January of 2026. Subo Dong, the lead researcher, said simply, "We know for sure it's a planet. A Saturn drifting alone 10,000 light-years away. It has no sun, no companion. It moves through the dark at the speeds of normal galactic motion, perhaps 200 kilometers per second, relative to the stars around it. It has been doing so for possibly billions of years. It will continue to do so, perhaps, for billions more, just one of trillions." What is it like to be a rogue planet? Of course, no rogue planet experiences anything in the way we do. There is no consciousness on these worlds, at least no consciousness we have any reason to believe in. They are simply objects, cold rocks, frozen gas giants, dark spheres drifting through the void. But we can imagine the experience. If we could stand on the surface of a rogue planet, somehow, what would we see? The first thing we would notice is the darkness. There is no sun overhead. There is no warm light to illuminate the landscape. The sky is filled instead with stars, distant, faint, and uncountable. They are the same stars we see from Earth on a clear night, but they are scattered across the entire sky. There is no horizon between day and night because there is no day. The second thing we would notice is the cold. Without a sun, a rogue planet has no significant external heat source. Whatever heat it has comes from its own internal geology, radioactive decay, residual heat from its formation, and from the slow trickle of starlight from the rest of the galaxy. For a rocky rogue planet, one the size of Earth, the surface temperature would be close to absolute zero, about -270 degrees Celsius. There would be no liquid water, no air in any meaningful sense. The atmosphere would have frozen and fallen to the ground, layered as solid ice, nitrogen ice, oxygen ice, carbon dioxide ice, covering the entire planet. The surface would be hard, glassy, mirror smooth in some places. Mountains and craters would still be there, frozen in place, but they would be wrapped in layers of ice as deep as continents. The third thing we would notice, if we waited long enough, is how slowly time seems to pass. A rogue planet has no day-night cycle. There are no seasons. There is no orbital year, because there is nothing to orbit. The planet rotates on its axis, perhaps, if it had a rotational momentum from its formation. But the rotation does nothing. The star field above shifts slowly, but no part of it ever brightens. There is no morning, there is no sunrise. The same dark sky, full of distant stars, is overhead for billions of years. This is what most of the universe is like, by mass and volume. The bright places, the planets in their orbits, warmed by their suns, are extraordinarily rare. Most of the universe is empty space, illuminated only faintly by the most distant stars. A rogue planet drifts through this empty universe with no companions. It interacts with almost nothing. Occasionally, perhaps once every few billion years, it may come close to a star. The gravity of the star may bend its path slightly. It may gain or lose some velocity, but it does not stop. It does not enter orbit. The encounter is brief, a few thousand years at most. Then the rogue planet drifts away again, carrying a slightly different trajectory into the next stretch of empty space. It will not be captured by the star. The geometry simply does not allow it. To enter orbit, the rogue planet would need to lose energy, and there is nothing in the empty space to absorb that energy. So it continues, briefly slowed, briefly accelerated, but always continuing onward. This is the rhythm of a rogue planet's existence, drifting, encountering, continuing, drifting, encountering, continuing, for periods of time longer than the existence of life on Earth. Some rogue planets may have escaped from their solar systems billions of years ago. They may have been wandering for far longer than there has been any complex life anywhere in the universe. They may continue to wander long after our own sun has died, long after the Milky Way has merged with Andromeda, long after the recognizable shape of our galaxy is gone. They are some of the most patient objects in the cosmos. Most of them will never be seen by any conscious being. There are simply too many. The galaxy is too large. They emit no light. They are invisible. We can detect a few when their gravity briefly bends the light from a star behind them. We can see a few when they are very young and still glowing faintly with the heat of their birth. We find them, occasionally, in pairs, but the vast majority are invisible to us. We can only estimate from theory how many there must be. Trillions, drifting silently through the dark, each one a world. When you look up at the night sky tonight, take a moment to consider this. Between every star you can see, there are many invisible worlds. The closest stars to us, Alpha Centauri, Sirius, Procyon, are between 4 and 10 light-years away. The space between them is, by our usual experience, immense, empty, cold, but it is not entirely empty. Recent statistical estimates suggest that within a single light-year of our Sun, there are probably one or more rogue planets. Within 10 light-years, there may be dozens. Within 100 light-years, there may be thousands. We do not know where they are. They emit no light. We could not see them, even with our best telescopes, unless they happened to pass directly between us and a distant star. And even then, only for a few hours of dimming or brightening before they continued on. But they are there. In the year 2027, NASA plans to launch the Nancy Grace Roman Space Telescope, a next-generation infrared observatory designed in part to find rogue planets in our galaxy. Its primary mission will include something called the Galactic Bulge Time Domain Survey, in which it will continuously monitor a portion of the sky near the center of the Milky Way, watching for the brief micro-lensing events that betray the presence of dark objects between us and the stars beyond. Astronomers expect Roman to discover hundreds, perhaps thousands, of rogue planets, some smaller than Earth, some many times larger than Jupiter. By the end of its mission, the population of known rogue planets will be transformed from the few dozen we have today into a robust statistical sample. We will, for the first time, have a real census of these worlds. They will turn out to be more diverse than we have imagined. Some will be Earth-sized. Some will be the size of Mars, or smaller. A few will be giant, closer in size to Saturn or Jupiter, or even larger. Some will be ancient, formed in the early universe, billions of years before our own solar system. Some will be young, recently ejected, still warm with the heat of their formation. Each one is a world. And here is something strange. Some rogue planets, we are now beginning to learn, may have moons. In the year 2025, an international team led by the University of St. Andrews used the James Webb Space Telescope to study 8 free-floating planets in detail. 6 of them showed something extraordinary in their infrared spectra, warm dust surrounding them, in the same way that protoplanetary disks surround newly formed stars. The dust suggests that small bodies, moons, or planets of planets could form around these wandering worlds. A rogue planet, drifting alone through space, could have its own miniature solar system, a central giant with smaller bodies orbiting it. In the long darkness between the stars, there could be entire little worlds, not orbiting suns, but orbiting other planets, pale, cold, dim, but organized, coherent, mini-systems drifting alone. The cosmos, it seems, is more inventive than we ever expected. For every solar system we have catalogued, there may be a rogue system. For every star with planets, there may be one or more planets without stars. For every sun-like world, there may be a rogue companion drifting through the dark. The night sky is full of hidden worlds. We just cannot see them. There is one more question worth asking before we end our journey. Could a rogue planet hold life? The answer, surprisingly, is perhaps. Without a sun, the surface of a rogue planet is unimaginably cold, frozen solid, hostile to anything we would recognize as biology. There is no photosynthesis without sunlight. There is no liquid water on the surface. There is no warmth. But beneath the surface, things are different. A rogue planet, if it is large enough, perhaps Earth-sized or somewhat larger, generates internal heat. This heat comes from radioactive elements within the rocks, slowly decaying over billions of years. It comes from the residual heat of the planet's original formation, leaking outward over astronomical time. It comes from gravitational compression, as the planet's own weight slowly settles its interior. This internal heat is significant. In our own solar system, even the small icy moons of the outer planets, Europa, Enceladus, Titan, have liquid water beneath their surfaces, kept warm by tidal heating and internal radioactivity. Beneath miles of ice, there are oceans, possibly with chemistry capable of supporting microbial life. A rogue planet, with its own internal heat source and a thick atmosphere of frozen gases insulating its surface, could maintain liquid water deep beneath its frozen crust. The conditions may not be wildly different from those at the bottom of Earth's oceans, around hydrothermal vents, where life thrives without sunlight in our own world. If life exists on a rogue planet, it would not look up at a sky. It would live in eternal darkness, in pressure-rich liquid water fed by chemistry. The chemistry of hot rock meeting cold water. The chemistry of trace minerals dissolving slowly through the eternal night. It would live in a world it could not perceive, a world without horizons, without seasons, without a sense of the rest of the universe. It would be a kind of life we have never imagined. Some scientists go even further. They suggest that the most numerous habitats for life in the universe may not be planets orbiting stars like Earth, but rogue planets drifting through the dark, hiding warm oceans beneath their frozen surfaces. If this is true, then the universe may be far more populated than we have assumed. Not by surface civilizations like our own, those would be vanishingly rare, but by deep, hidden, microbial life in the darkness between the stars. Life in the universe may not be as rare as we think. It may simply be hidden. In worlds we cannot see, beneath ice we cannot pierce, in oceans no light has ever touched. This is, of course, speculation. We have no evidence of rogue planet life. We may never have evidence. These worlds are too far, too dark, too difficult to study. But the possibility is real. The cosmos may be quietly humming with life in places we will never visit. We have come to the end of our journey. We have walked among the rogue planets. We have seen worlds that were born without a sun, formed alone in the cold spaces between stars, never having known the warmth of a parent star. We have followed planets that were violently ejected from their solar systems, cast out by the gravity of their siblings, never to return. We have drifted across the deep emptiness with them. We have stood in imagination on their dark, frozen surfaces, beneath skies that hold only distant stars. We have imagined the slow, patient passage of their existence, billions of years of nothing but starlight and silence. We have learned that they are everywhere, trillions of them, in our own galaxy alone, more numerous perhaps than the stars themselves, drifting between every star you see in the night sky. And we have asked gently whether life might still be possible beneath the frozen surfaces in oceans that have never seen a sun. The cosmos is far stranger than we ever imagined, far more populated, far more patient. Tonight, when you go to sleep, somewhere out there, a rogue planet is passing through the empty dark. It has been drifting for billions of years. It will continue drifting for billions more. It has no awareness of you, or of the Earth, or of the Sun, or of any of the brief dramas of our small, bright world. But it is there, a world without a sun, patient, cold, quiet. And there is something peaceful in knowing that such places exist, that not every world is like ours, that not every place in the cosmos is full of light and warmth and motion, that some worlds simply drift, that the universe is large enough to contain them, that you tonight are warm, breathing, resting, while somewhere in the dark, the wandering worlds continue. Sleep well. The cosmos keeps watch. Good night.